Hello, in this presentation we'll cover the design and implementation of an automatic generator for word matching interactives. An automatic word match generator is a software tool that can be used to generate word matching interactives automatically. The purpose of a word matching interactive is to provide students with a mechanism to learn new vocabulary and improve their reading comprehension skills. This thesis will present the design and implementation of an automatic word match generator, as well as the research and algorithms used in the program. A brief outline is provided for the presentation. We'll cover the problem motivation, review of literature, methodology, and conclusion and results. So, the problem motivation. Students tend to face difficulties when they are required to learn new terminology. For example, understanding how to differentiate between the terms hardware and software can be challenging for beginner computer science students. Word matching games have been used by instructors to teach vocabulary to students. Previous researchers, Artifa and Krishnamurti, utilized a technique called make-a-match, which has been shown to be successful for teaching vocabulary. Riadatta and Nikma and Hussain iterated on this concept. They used pictures in words, and a company called Fast Forward Products developed a set of software-based word matching games that were shown to help improve reading comprehension and vocabulary skills through a test known as the Brigance Comprehensive Inventory of Basic Skills, essentially a learning curve. And Google Trends showed that Udemy usage increased during the pandemic around March 2020. This could be an indication that there was an uptick in usage of online learning, and the fact that this trend has fizzled out could also indicate that online learning is now accepted. Platforms like Revel, which are an online learning platform, use interactives which have been shown to help students improve their average Quizlet grades. Now we'll discuss the review of the literature. Figure 3 shows an example of a make-a-match exercise. Masari and Najjar created the concept of make-a-match. However, their example used words and descriptions on cards. Nikma and Hussain used an alternative method that leveraged pictures and words, as opposed to Masari and Najjar's example, or even Artifa and Krishnamurti's method, which used just cards with words. In both cases, with Masari and Najjar and Nikma Hussain's experiments, the experimental group performed better than the control group. Specifically, Nikma and Hussain's research revealed post-test scores of 80.40 for their experimental group and 77.20 for the control group. And the measured p-value of the post-test score was less than the significance value of 0.05, thus rejecting the null hypothesis, accepting the alternative hypothesis, meaning that this supports the argument that word matching interactives help students improve their reading comprehension skills and vocabulary skills. Figure 4 demonstrates that students gained 3.5 years in reading grade level, and their average letter word identification improved by 14 months, and their average gain on the passage comprehension subtest of the Woodcock-Johnson 3 tests of achievement in 2 years. This red line here indicates that students were able to consistently improve their word matching capability. As you can see, it says the days of participation on the x-axis and the average percent complete on the y-axis. If we look at this trend, we can see that the curve stabilizes over time, and thus the consistent practicing of these word matching games led to an improvement in overall reading comprehension and vocabulary skills. This figure shows that there was a spike in Udemy usage during the pandemic, specifically in March 2020. You can see that here. It is possible that this peak can be attributed to the forced isolation brought on by COVID-19. The consequences of the pandemic were unstoppable and uncontrollable for higher education industries, much like the rest of the world. Most higher education systems are now operating through e-learning platforms. It is possible that the stabilization of this curve implies that the world has adopted the usage of online learning platforms like Udemy, Unacademy, Swayam, and edX. And our research will help students who are either studying remotely or working remotely, as well as instructors who are teaching remotely. Now we'll discuss the successive interactives used in Revel. Revel is a program used both at home and in class. It is an online learning platform. It provides students with a process for practicing what they've learned, and Revel Interactives provide integrated live examples that help students improve retention of key programming concepts through the application of running and modifying live code. Figure 5 shows a strong positive correlation exists between average Revel grades and average quiz grades, where R is equal to 0.50 and P is less than 0.01. Figure 6 shows that the higher the Revel grade, the higher the average exam grade, lab grade, and final course grade. As you can see, the grade increases from a 60 to a 77%. Figure 7 shows that there's a strong positive correlation between Revel grades and final course grades, where R is equal to 0.67 and P is less than 0.01. Figure 8 shows that the higher the average Revel grade, the higher the average quiz letter grade. In this case, we have an increase from 78% to 90%. Figure 9 shows that the average Revel grade increased from 59% to 70% from spring of 2015 to fall of 2015 for students who used Revel. In Figure 10, we see a two-sample t-test. So a t-test measures whether the means of two groups are statistically different. And Figure 10 shows that the average exam grades for spring of 2015 and fall of 2015 in this study had a change. The results of the t-test show that in fall of 2015 there was a mean of 70% as compared to 2015, which was a mean of 59%, using a sample size of 118. This indicates that there was a statistical significant difference between fall of 2015 and spring of 2015. That implies that there was an increase in student performance. They were able to improve their grade using Revel. Now we'll discuss the requirement specification. So, instructors shall be able to automatically create interactive word matching games. Students shall be able to access games online. From a developer's perspective, the following specifications were required. Number 1, enable the storage and retrieval of word matching interactives. 2, create input data necessary to create word matching interactives. Number 3, provide a web interface for displaying word matching interactives. Number 4, develop a drag and drop algorithm that facilitates an interactive learning experience using the derived data from the output. Figure 11 shows a before and after picture of the automatic word match generator. In the top left, we have the first example, which was just simple HTML and JavaScript. In the bottom, we can see a full-scale custom 3-tiered application, which was created specifically for developing word matching interactives. As you can see, we have a display, which is the view that's presented to the user. When an instructor clicks the post button, a request is sent to a handler. That handler processes the request, which is then sent to a controller. The controller then calls a service method, which then processes the content sent from the request and saves the file onto the server. After that file has been saved to the server, it's now accessible for a student to access. When a student visits the specific URL with the ID associated with that exercise, a GET request is made to the handler, and then that handler processes the request, which is sent through HTTP protocol. The controller then processes this route. This route then is associated with a method in the service, and that service will send back the data if necessary. In this case, it will just pull in the file from the server, and it'll show the word matching interactive associated with that ID. So now we'll discuss the implementation of the automatic word match generator. So we selected languages for developing the program, then we identified the expected output for the program, Then we created a proof of concept that collected the data needed to generate the derived data to create a word matching interactive. Then we developed a user interface for collecting this input data. We implemented an HTML generating function, which was used to collect input data and generate the derived output data. Then we implemented an HTML rendering function to display the expected output with the derived data. Then we developed a system for displaying the output to the user in a separate view. So, we selected these languages based on the experience between Dr. Liang and myself. We both have a strong familiarity with Java, and we identified the input and output based on the simple example that we started with, the first word matching interactive, which featured HTML and JavaScript, just a simple example. Then we implemented the functionality based on the requirement specification. We'll discuss what a word matching interactive is in subsequent slides. Now we'll get into the algorithm design. So, the word matching interactive is set up, and then this algorithm is what processes the user interaction. So first we obtain the index of the dragged key term as the source index. Then we obtain the index of the row where the key term is dropped as the target index. The crux of this algorithm is this conditional statement, which is the comparison of the source index to the target index. If the source index does not match the target index, the key term is then returned back to its original position. If it isn't, then we disable the key term object to be undraggable. Then we set a new color for the matched row object. Then we test if all key terms are matched. If so, we display congratulations dialog box and increase the success count by 1. Now we'll go through the testing phase through a simple example. So, Figure 12 presents the user interface that will be presented to an instructor. Figure 13 shows the user interface after it has been pre-populated with key terms and descriptions. Figure 14 shows the instructor interface after the static HTML has been generated. The window at the bottom of the page shows the code used to create a word matching interactive. That little window right there will provide an instructor with a full view of all of the code used in creating a word matching interactive. Figure 15 shows the instructor user interface after the word matching interactive has been posted to the server. The view button is now visible, which can be clicked, and then it will take the user to the view associated with the word matching interactive that has just been created. Figure 16 shows a word matching interactive that features the key terms and descriptions from Introduction to Java Programming by Dr. Daniel Liang. So, our research is based on generative programming and code generation. Generative programming is the application of reusing code for a new function or software. We are able to recycle the code for a new purpose without having to rewrite it. The HTML that we are generating is written. We don't need to rewrite it. An instructor can just click a button and then they get this output, which is a word matching interactive. And we applied code generation, which is a mechanism to produce an executable form of a program. The template that we have here is the word matching interactive that we have produced. We'll take a look at automatic programming. So, a generic input can be applied to a process, right? In this process, a web page output can be generated. In the case of the automatic word match generator, input is entered from text fields and stored in arrays. Then validation checks if key terms or their descriptions are empty. Then in process data, data is shuffled randomly and the key terms are mapped with descriptions. And then we create a web page which is used to create HTML and CSS and JavaScript to produce a word matching interactive. Finally, we post a web page which automatically displays the code to a user. The post web page posts the generated web page on a web server so that the page can be viewed on the internet. The results from previous researchers and the evidence shown from figures 4 through 9 indicate, number 1, that word matching interactives provide students with the intent to improve their vocabulary and reading comprehension skills, as shown by the learning curve and fast forward products. And number 2, interactives have been shown to improve student performance on quizzes and tests as shown by the test results from Revel. We can take a look at a live example here. So click on this link. Okay. In this case, the live version of the word match generator isn't accessible. That's not a problem at all. We can go ahead and use a local version. This local version is the same exact code. We will enter a quiz here. So we'll do Spanish quiz. And we'll enter caballo, horse, burro, donkey. Then we'll go ahead and generate the HTML. We can see the generated HTML here. Go ahead and move this up. So this shows all the generated HTML. Now we'll click Save. And we'll click the View button. This takes us to the Spanish quiz word matching interactive. So we'll drag the key terms to the descriptions. First we'll try and drag it to the wrong description. So the key term is sent back to its original position. The key term is sent back to its original position. Now we'll activate the speech synthesis, which will help individuals who struggle with hearing, who struggle with understanding the text. This provides them with the ability to hear what the key words are and descriptions are. So we'll drag this over to horse.
Cabello, horse.
And we'll drag this over to donkey.
Burro, donkey.
Okay. We can check to see the answer, which confirms show answer. We can click the reset button here. This reset button sends the key terms and descriptions back to their original position. If a student is stuck, they can click on show answer, which will present them with the key term and the description. Okay. Are there any questions? So perhaps someone might think that there's an alternative method for creating word matching interactives. Perhaps they're familiar with other word matching interactives. A quick Google search will reveal a couple of examples. However, these examples are not that great. We can take a look at one of these. So there's a particular example called the Teacher's Corner where you can make your own matchup. This site is ineffective because it is covered in ads. It's frustrating to use. Just trying to type in a key term and definition opens an ad tab, and it was not made for instructors. It's really just a gimmick. So if we go here, you can go ahead and step one here, we have to actually go in here and click Matchup Maker. So this takes up time. So go ahead and write Spanish quiz. So this requires manual input, and then write the letter of the correct term to match this. So this quiz will test a student's Spanish knowledge. Okay, and we have a caballo, horse, burro, donkey. We'll go down here and we'll generate our matchup worksheet. So, user interface is pretty bad. It's a really bad experience. You have to see that this has to be clipped here. Open and close. Barely works. Then you type in something here. It's not interactive. It requires you to print out a sheet. That's not really ideal. There's also distracting ads, which just are going to encourage students to navigate away from what they're supposed to be doing, which is studying. So, just kind of overview here. This is what this looks like, right? It's a very complicated mess of things, tons of different things, too many choices. It's not simple. And again, you have to print this out. It isn't an interactive thing that you can use online. And given the trends that we've seen from Google, it looks like there's massive usage of online platforms. And this word match generator that we've created can be used to help students learn online. So you can also see that these word matching interactives are being used in Revel, and it's a part of the Revel curriculum, which helps students improve their ability to learn computer science, and it also improves their average grades, as we've seen from the statistics shown in figures 4 through 9. Any other questions? Okay. If anyone has any questions, please just let me know. Thank you.